Look at this one. Oh, you're such an university. The next one is a Stars Pro. Später will ich sagen, zum Beispiel gibt er das Link-Dokument, was möglich ist. Ja, dann ist es natürlich schön, wenn ich das dann auch Step und direkt an den Catch rein. Sie das dann als ein Ärger von
So you say blah blah blah.
Yeah, so put this in your pocket.
Achso, das ist ja nur eine.
I'm going to put this. Sorry about that.
Okay, we can approximate now.
Does anyone want to share? One side. Extra large. Okay.
And Excel?
Okay. We'll continue later. We're gonna do the talk now.
Okay, so
Do you need electricity or not?
no, that should be fine.
Okay, you should fine. Perfect. So please sign on your phones.
It's okay. Okay, so I have the very hard task to keep you awake for the next 10 minutes. Just to introduce a bit myself, I'm Nicolas Perru. I work at SonarSource, which is the company behind SonarCube. I don't know if some of you knows or use it. I'm a developer in the language team, so I work mainly on analyzers and mainly the Java analyzer. And you can find me cycling around the Le Mans or at the Geneva Jug, so the Java user group. Okay, what I'm going to talk about is a bit the backstory of how we came up with actually doing developing some analyzer at SonarSource and what we did to develop them. So just to understand a bit the context, at SonarSource we have this product called SonarCube, which helps you to track issues over time on your project. So which bugs, how do you fix them, and everything, and track metrics as well. And the project started somehow as an aggregator of other linters, and at one point in time there was the decision and the fact that, okay, we need to develop our own analyzers because it was not so easy to contribute back. The technology, there was some limitation in existing linters that we at least thought we were trying to be able to fix or to overcome. So we said, okay, cool, now we want to have a static analyzer in Java. How do we do that? So I'm going to explain and walk you through how do we develop a static analyzer. There's quite some stuff that were already explained in previous presentations, so that's going to be quick on some parts. So the main challenge here is to get the language. So guess what the first thing is? We start to do some parsing. So that's a recurring thing here in this room, right? So as we do exactly as Federico described through presentation before. So we have this lexical analysis, then we have the syntax analysis. We end up with a syntax tree which describes the language and on which we can work. We have a bunch of rules already we can implement with that, mainly rules about formatting, kind of what we call somehow code smells. So problems, that's what we call them. Mainly problems around like, is this if on the right line? Is this token on the wrong line? Is this commented enough? Everything. The syntactic equivalence that was described also by those other guys this afternoon, like do you have the same operand on both sides of an operator? Is that probably an issue? So we can already work with that and have some rules. Then we have another layer. We go for semantic analysis. So we resolve all the symbols. So this is not always easy in Java. This is the easy part. Then we enter the realm of generics and type inference, which is just so nice, so much fun. And the good thing is that all what I've said, all what I've mentioned, you can use that to actually write your own checks for SonarCube and to have your own Java checks available to analyze for your project. So please use, and please let us know how bad is our API so we can improve it. But that's not all. That's the nice part. We can do all code smell, pretty advanced code smell. We can start to try to detect some bug with this, but we implemented also symbolic execution to be able to detect some bugs. And You might wonder what actually is symbolic execution, and that's going to be the main part of this very short talk to explain a bit to you what we're doing with that. So the main goal is to try to detect this very complicated hidden null pointer exception here and to be sure that it's a null pointer. We want to be really accurate. We don't want to raise too many issues. When we raise an issue, we want to be sure it's an issue. We don't want to raise false positives. So that's really why we are using symbolic execution to reduce the amount of false positives. So how do we do that? So we start by having this project, this source file, sorry. It all works within a method. And so we start by saying, okay, we have a state of the program where we know that here by definition we assign something, so this myObject is not null. Then we go along the execution, we simulate somehow the execution, and when we reach a condition, we actually have two possible outcomes. We don't know about the condition A, so either A is false and so myObject is still not null, as we started, or A is true and then myObject is null. So we now have two possible states of the program, and so we continue the exploration. So continuing the exploration, we reach the second condition, so it's not A, so then we start with the first state, and we say, okay, A is false, so there is one state that is possible, the true, we can actually go into that condition. It's not very interesting, let's move on. And the second part, we can't reach it. A is false, that's not possible. Okay, cool. Nothing interesting, no more to see here. Let's look at the other state. The other state, we have myObject, which is null, A is true, so the true part of the if is actually not feasible, so we don't explore anything. And on the second part, we actually have myObject, which is null, A is true, and oh, hold on, with dereference myObject, it's null, we have an issue here. And so we were able to detect the null pointer exception like that. And we are context sensitive, we follow those paths as well. And that helped us to find those issues. This is really an interesting technique. It gives a lot of very nice results. It has some drawbacks, of course. Drawbacks mainly are when you have really, really complex conditions, because obviously, as you have all computed in your head right now, this is always true. And so you end up in the realm of satisfiability, solvers, and everything. And so this is really a challenge we have to face at one point. Right now, we don't handle ints, and so that's one thing we didn't address yet. Who knows, maybe soon. Another problem is also explosion of states. Here we had only one if, so that's already two states. You can imagine that if you nest a lot of conditions, a lot of loops and everything, the number of states to actually keep track of can quickly grow. And so then you have the problem of how many computations you will have to do. So you have a lot of techniques to try to optimize this, to reduce the number of states, find some equivalence between some states of the program. So that's a challenge. And another challenge as well is that this is only intra-procedural, so it's only within a method. So how do you actually try to find some bugs that can be between methods? And so this is actually, we started a bit with this on cross-procedural, and it's not actually, we're still working on that. And what we have for some plan in the future, oh, okay, no, sorry, I forgot about that one. So just a small example of what we can detect that is interesting. So this is taken from Apache Viper, so it's an open source project. Actually, no idea what it does. But we found this nice bug. So basically, we have this object here. This condition here is such that we know that if we don't reach it, if we don't enter this part here, we know that the variable 2 is not equal to server entity, so which means here, this assignment, this value here is always false, so that condition is basically useless, so there's probably something wrong here. So it's actually a quite nice finding. And we can find some stuff like that. And for the future, we want to try to address state analysis, so trying to find some vulnerability issues between files, a lot like what Jules described in his fair talk previously this afternoon. I'm not going into details here. SonarSource is recruiting, so send your CVs. And if you have questions, start now. I think I'm on time. 10 minutes is awfully short. Jacob, please go ahead.
Did you use Java parser for that, or did you write your own? And
No, we have our own. We have our own. Oh, sorry. Did we use Java parser or Java or anything? No, we have our own stack of parsing. So
but it's open source.
It's all open source, all available on GitHub. There's the link on the talk.
On the slide where you show the bug, it says reported 2 years ago. So what happened to it since?
That's a very good question. So the example, the example I showed, was it did something happen to it? On this very specific case, I don't know, but we reported it as well. We reported also, we have the same kind of technology also applied on .NET, on C# code, and so, but for that they use actually a front end which is Roslyn, which is open source, and actually find bugs in Roslyn using Roslyn, and they report it back to Roslyn, which is fun.